Hi to everyone, welcome to NCC channel. My name is Naresh Chemistry Lecturer. Today we solve some questions based on FAJAN'S rule and dipole moment. The first question is arrange the following in increasing order of their covalent character. Arrange the following in increasing order of their covalent character. CaF2, CaCl2, CaBr2, CaI2. Here given some molecules. We have to find out covalent character order. CaF2, CaCl2, CaBr2, CaI2. So covalent character is directly proportional to anion size of anion size, and inversely proportional to size of cation size. Already you know that. Already I given one code, that is CA. That means chartered account. That means covalent character is directly proportional to size of anion. If the anion size is more, covalent character is more. If the anion size is less, covalent character is less. Given molecules CF2, CaCl2, CaBr2, CI2. Positive, negative, cation, anion, cation, anion, cation, anion, cation, anion. All cations are same and anions are different. When we are moving from top to bottom, the size of anions increases. If the anion size is more, covalent character is more. Now it is more covalent character. More covalent character. Now we are moving from this one to this one. Now further the size of anion decreases, so more covalent character also decreases. Now moving to this one, further the anion size decreases, covalent character also decreases. Now moving to this one, the anion size also further decreases, covalent character also decreases. Now it is least covalent character, because the size of anion is very less. That's why covalent character is very less, least covalent character. Now the option is CIT is the more covalent character. D is more covalent character, followed by CaBr2, followed by CaCl2, followed by CF2. Option B is the correct answer. Now we solve second question. Arrange the following in decreasing order of their covalent character. Arrange the following in decreasing order of their covalent character. LiCl, NaCl, KCl, CSCl. LiCl, NaCl, KCl, CSCl. Cation, anion, cation, anion, cation, anion, cation, anion. Here anions are same but cations are different. Here covalent character is already you know that covalent is Ca. Covalent character is directly proportional to size of anion and inversely proportional to size of cation size, anion size. If the cation size is more, covalent character is more. If the cation size is less, covalent character is more. If the cation size is more, covalent character is less. Now we have to find out the size of cations: lithium, sodium, potassium, cesium. When we are moving from top to bottom, the size of cations increases. Now the least size is Li plus. So size of this cation size is less. That's why covalent character is more. Covalent character is more. And moving to this one, size increases, covalent character further decreases. Moving to this one, size of cation increases, covalent character further decreases. Now now moving to this one, this is more size, larger size. That's why covalent character further decreases. It is least covalent character. Now more covalent character is LiCl, A. Next followed by NaCl, KCl, CSCl. So the order is ABCD. Answer is C. Next question. Among LiCl, RBCl, BeCl2 and MgCl2, the compounds with the greatest and least ionic character respectively. Greatest and least ionic character. Greatest means more ionic character, and less ionic character we have to find out. Given LiCl, RbCl, BeCl2, MgCl2 given here. This is cation anion, cation anion, cation anion, cation anion. Now all anions are same, all anions are same, and cations are different. And we have to find out ionic character. Already one code I have given one code, that is IC, intensive care. That means ionic character is directly proportional to size of cation size, and inversely proportional to size of anion size. Now we have to find out ionic character in these compounds with more ionic character and the least ionic character. We have to find out. Okay, cation size is more, ionic character is more. We have to find out which cation is more size, so that is more ionic character. And we have to find out which cation is less size, that is the least ionic character. Lithium, sodium, potassium, rubidium, cesium, and beryllium, magnesium. These are the positions in the periodic table. When we are moving from top to bottom, the size increases. Now in this rubidium ion is more size. Cesium not given here. Rubidium size is more size. That's why if the cation size is more, ionic character is more. Now RbCl is more ionic character. Now we have to find out the cation which is least size, small size. Now lithium, beryllium. In this, which one is small size? Which cation is small size? Lithium, beryllium. We think lithium is small size because it is first place, but it is not correct. These are belongs to same period. When we are moving from left to right, the size decreases. That's why it is small size. Beryllium ion is small size. If the size of cation is less, the ionic character is less. Now BeCl2 is the less ionic character. First greatest ionic character. What is the greatest ionic character? RbCl. RbCl is the greatest ionic character, and least ionic character is BeCl2 is the least ionic character. The answer is B. Next question. Among BF2, BF3, H2O, NH3, CCl4 and HCl, the number of molecules with non-zero dipole moments. Already you know that symmetrical molecules dipole moment always 0, and unsymmetrical molecules dipole moment is not equal to 0. We have to find out non-zero dipole moments. That means if you find unsymmetrical molecules, you can find the answer. So symmetrical molecules always dipole moment 0. For unsymmetrical molecules, dipole moment is not equal to 0. So which molecules are symmetrical and which molecules are unsymmetrical? Symmetrical molecules, BeCl2, it is linear shape, it is just symmetrical, and the dipole moment is 0. And boron trifluoride, it is trigonal planar, it is a symmetrical molecule, that's why dipole moment 0. CCl4, carbon tetrachloride, it is tetrahedral shape and it is a symmetrical molecule, that's why dipole moment is 0. XeF4, it is square planar, it is a symmetrical molecule and the dipole moment is 0. SF6, it is a octahedral, it is a symmetrical molecule, that's why dipole moment is 0. These are the symmetrical molecules, and dipole moments also 0. Next, unsymmetrical molecules. We see unsymmetrical molecules. H2O bend shape, it is a bend shape, it is unsymmetrical, that's why it is dipole moment is not equal to 0. And ammonia, it is pyramidal shape, it is unsymmetrical shape, and hence it is dipole moment is not equal to 0. T shape, ClF3, it is a T shape and it is unsymmetrical. It is an unsymmetrical molecule, hence dipole moment is not equal to 0. SF4, C-cell structure, it is unsymmetrical shape, hence dipole moment is not equal to 0. BRF5, it is square pyramidal, it is unsymmetrical shape, and dipole moment is not equal to 0. These are unsymmetrical molecules. H2O, NH3, ClF3, SF4, BRF5, these are unsymmetrical molecules, that's why these are unsymmetrical. Dipole moment is not equal to 0. Now given here, BF2, it is linear shape and symmetrical, that's why equal to dipole moment equal to 0. Boron trifluoride, BF3, it is symmetrical, trigonal planar shape and symmetrical shape, that's why dipole moment equal to 0. H2O, it is bent shape, it is unsymmetrical, mu not equal to 0. NH3, pyramidal shape, it is unsymmetrical, mu not equal, dipole moment is not equal to CCl4. Next to CCl4, carbon tetrachloride, it is it is symmetrical, mu equal to 0. Next BF2, it is a symmetrical, dipole moment equal to 0. Next SCl, in SCl, chlorine is more electronegative nature. It can attract the bonded electrons towards itself. It gets partial negative charge, partial positive charge, hence it has a dipole moment. So mu not equal to 0. So how many molecules are non-zero dipole moment? 1, 2, 3. So answer is 3. The remaining are dipole moment 0. So next question number 5. The dipole moment of CCl4, CSCl3 and CH4 are in the order. We have to find out the dipole moment order. CCl4, it is carbon tetrachloride. It is tetrahedral shape. Already you know the tetrahedral, it is symmetrical. So dipole moment equal to 0. CH4, tetrahedral, symmetrical shape, dipole moment equal to 0. CSCl3, even though it is tetrahedral, but the atoms are not identical. These are carbon tetrachloride, CH4 methane, and these atoms are identical. All 4 atoms are identical. In this, all 4 atoms are identical, but in this CSCl3 chloroform, 4 atoms are not identical. Even though it is tetrahedral shape, even though it is symmetrical shape, even though it is symmetrical molecule, so mu not equal to 0. It has some dipole moment. But CCl4 and CH4 dipole moment is 0. CH4 and CCl4 dipole moment is 0, and CSCl3 has dipole moment. So it has dipole moment. The dipole moment is greater than these molecules. So the correct order is like this, D. Now, which one of the following molecule is polar? Already you know that the molecules which has dipole moment, the molecule dipole moment is equal to 0. Dipole moment equal to 0. If the molecule has dipole moment equal to 0, that is non-polar. If the dipole moment is not equal to 0, that is polar. Molecule. If the dipole moment is 0, that is non-polar molecule. If the dipole moment is not equal to 0, that is polar molecule. XCF4, it is a square planar. It is a symmetrical, equal to 0. It is non-polar. And next CF4, it is tetrahedral, symmetrical, equal to 0. SBF5, it is pentagonal bipyramidal. It is symmetrical, equal to 0. IF5, it is a square pyramidal. For square pyramidal, it is unsymmetrical, mu not equal to 0. It has polar molecule. That's why it is a polar molecule. So option is IF5. So these are the questions we solve. I hope that all are understood these questions. Thanks to all for watching my video.